All right, so 5.4, we're going to talk about systems of nonlinear equations in two variables. The first part here just wants us to identify the shape of the graph of each of the equations. So what type of a function is number one? Is it linear, quadratic, cubic, conic? It is linear. And what type of a graph is that going to give me? What's it going to look like? Is it a parabola, circle? It's a straight line. What about number two? It's going to give me a parabola because it's a quadratic function, right? So what about number three? Well, it's considered a conic, and it's going to give us a circle. Remember, it's the standard form of the circle. The x minus h squared plus y minus k squared equals r squared. What about number four? It's also a conic. And do you notice it has x squared plus, and it's got y squared? There's no numbers in front of the x squared and the y squared, and because it's a plus, that's also a circle. Number five has an x squared and a y squared, so it's going to be a conic. But unlike the one above, it's got a 4 in front of that x squared. So because it's got the number there in front of the x squared, but it's still being a positive y squared, okay? That's going to make it what they call an ellipse. I'm really not making up words. So an ellipse will look like a set of lips or a football, whichever way you want to look at it, okay? And then number 6 there, notice it's got the x squared and the y squared, so we know it's going to be a conic. But this time it has a minus in the middle there, in front of the y squared. So that's what they call a hyperbola. Looks like hyperbola. Hyperbola, which is like two parabolas facing away from each other. So look like that, or it could look like this. So the first part here tells us now we're going to solve each system by the substitution method. So remember, with the substitution, you need either an equation solved for x or for y, correct? And this is very similar to what we did, except for the only difference between 5.1 and 5.3 is these are not all linear. So the second equation is not a linear. So how can I solve using substitution on this problem? Yeah, substitute the second equation into the first one. So my first equation is x minus y equals -1. And we're going to substitute in for y. And we know y is x squared plus 1. So x minus x squared minus 1 equals -1. What can we do there? Yeah, we're going to need a factor, so we need it set equal to 0. So I'm going to just move this one over. So I get x minus x squared, and that cancels, so it equals 0. So how do I factor that? Greatest common factor. So I can take out an x, which leaves me with 1 minus x. And then we got two things being multiplied, so set them both equal to 0 and solve. Alright, so we found x is 0 and x is 1, correct? So I'm going to have two solutions here. So I need to find the y value for each of them. So when x is 0, well, remember, we know that y is equal to x squared plus 1. So plug in your 0. And so we get y equals 1. So we have the ordered pair 0, 1. And then when x is 1, plug it in. And so we get the ordered pair 1, 2. And so our solutions there we saw were 0, 1 and 1, 2. And how can I check that? Yeah, plug each of them back in. So plug 0, 1 into both equations, it better make it true. And plug in 1, 2 into both equations, and it needs to make it true. So how about number 8 here? How can I use substitution here? Yeah, they're just set equal to each other basically because they're both equal to y. So if nothing else, I can say I'm going to take the second equation and I'm going to plug it in up there for y. So you end up with x squared plus 2x minus 1 equals x squared plus 4x plus 5. And so anytime you have what, x squared and x, you need to get it set equal to 0 because you're going to factor. So we need to move one of them to the other side. Does it matter which? No. So you want to move the left over to the right? Or the right over to the left? Right to the left. Alright, so you're going to say we're going to subtract all of these. And so what you do to one side, do to the other. Nice. It even made the x squared disappear, didn't it? So now I just need to solve for x. So I'm going to add the 6. And so we find x is negative 3. And so I only have one x to check to find the y value I meant. Sorry. So we know, you want to use the first equation or the second one? The second one? Okay, so we're going to use x squared plus 2x minus 1. And we're going to plug in x is 3. Oh, it's negative 3. That makes a slight difference, doesn't it? Yeah, so this should be a minus 6. And so we get 2. And so we only have one ordered pair on this one. So what about number 9 though? How are we going to do that? Well, I'm using substitution, so I need to solve for an x or a y. Be careful. If you use the second equation that has x squared or y squared, when you take that square root, you end up with a plus or minus, okay? So don't use that one. So I need to use the first equation, and I need to choose. Do I want to solve for x or y? Okay. She said y, so we're going to get rid of the x, so I'm going to have to divide by it. And so y equals 4 over x. So knowing that, now I can plug that into the other equation. Let's go ahead and square that one. Everybody okay with the squaring of it? I squared the 4 and the x. I don't like that fraction though. Do you? So how do we get rid of the fraction? Well, what does that fraction say? 16 over x squared, but what's another way to say it instead of over? Divide, right? And so if I want to get rid of something that's being divided, what do? Multiply. So we're going to multiply every term here by that denominator. So I have x to the 4th plus the x squared, there cancel, so I have 16 equals, and then 8x squared. And then what do we do when we have more than one form of the x? Because I have x to the 4th and x squared. We need to, what?
Bring it over to one side, right?
Yeah, we need to factor, so we're going to need a set equal to 0. So I'm going to move that 8x squared over. And so I'm going to write it up here. So I have x to the 4th minus 8x squared plus 16 equals 0. Can I factor that? Yeah. So I know it's going to be x squared and x squared because it needs to factor to x to the 4th, but that middle term there tells me I need x squared in it, okay? That's how we know it's x squared and x squared. And I need two numbers that are going to multiply to 16 that are going to add to 8. 4 and 4, and they're both going to be negative, right? All right, well, they're the same, so I only have to work it out once. But am I done factoring? No, because they're both difference of squares, aren't they? No. So x plus 2 times x minus 2 times the same thing. And if I set them all equal to 0, but when I go to do this x plus 2 equals 0 there, I already see I have it, right? That just means it's multiplicity of 2. And then the same thing with the x minus 2. I already have it written down there, so it's just got a multiplicity of 2. So we end up with x equals negative 2 and x equals positive 2. Now they both have multiplicity of 2, but I don't need that for this. That's the zeros, right, when we're looking for them. So I have two different x values, and I need to find y values that go with it. Now remember, we solved for y. We said that y was equal to 4 over x, didn't we? So when x equals negative 2, we know y is 4 over x. So we get 4 over negative 2, which is negative 2. So I know right there I get the ordered pair, negative 2, negative 2. And then when x is positive 2, we plug it into the y equals 4 over x. And we get y equals positive 2. So I know from that, x was positive 2, y was positive 2. And these are both my solutions. All right, now we're going to switch to the addition method. Remember, it's the same as elimination. So for that one, we need to pick a variable we're going to eliminate. Do we want to get rid of the x squared or the y squared? The y squared, it's already set up for me, isn't it? So negative y squared plus y squared is going to cancel. So I have 4x squared plus 4x squared is what? 8x squared equals 4 plus 4 is 8. So what is x squared? And what is x? And, yeah, remember you take the square root, you get plus or minus, correct? So you have two x's. You're going to have to find the y values for both of them. So which one do you want to start with, positive or negative one? Positive one. Which equation do you want to use, the first or the second? I'm going to say the second because I'm solving for y, and it's got a positive 1 in front of the y squared, okay? So I'm not going to have to divide by anything. So I'm going to use that second equation. I'm going to plug in x as 1. I'm going to subtract the 4, get y squared is 0, take the square root, and so y equals 0. So I know then when, I don't know why I'm trying to write x, when x is 1, y is 0. Now guys, if y squared had been like a 4, and we took the square root, we'd have got plus or minus 2. So that 1x would have had two y values, meaning I would have had two ordered pairs, okay? And then when x is negative 1, I'm going to use the same equation. Looks a little familiar, right? And so we found when x was negative 1, our y was also 0. And so these are my solutions. Look at number 11. Which variable do we have to eliminate? Yeah, the x squared, because we don't have, the other two variables aren't the same, are they? So we're going to have to eliminate the x squared. And it's not quite set up for me. One of these needs a negative number in front of it, doesn't it? Which one, top or bottom?
Oh, top.
All right, top. Only reason I said top is because I don't know if I want I don't know if I want a negative y squared yet. We'll see. All right, so we'll distribute that. So x squared's cancel. Now be careful, 2y and y squared are not like terms, so don't combine them, guys. So you got y squared plus 2y equals, and then we get 8. Well, what can I do now when I have more than one form of the variable? Yeah, we need a factor, so we need to set equal to 0. So I'm going to move the 8 over by subtracting it. Then we have our simple trinomial. So y and y, two numbers that multiply to 8 that subtract to 2. 4 and 2, positive 4 and negative 2. And then set them each equal to 0. And solve. Oops. All right, so we got two different y values. We're going to plug them both in. Do you want to use the first equation or the second equation?
First.
The first one, I think so, because it's got that y squared in the second one, right? I don't know if it'll really make that big of a difference. So let's try when y equals -4. So if we use the first one, and so we get x equals 0, right? So, you know what, I have this gut feeling we're going to have several solutions. So I'm going to come over here and write that one. So that one is what, x is 0 and y is -4. And so let's try when y is 2. I'm going to use the same equation. So x equals plus or minus, and we gotta go find the square root of 12. Now I want an exact answer, I don't want decimals, okay? So you have to come over here and break that 12 down. So that's what, 4 times 3? Yeah, so we have a pair of 2s, so it's gonna be 2, and then we have the 3 left over, so it goes back underneath. So 2 square root of 3. So what we have there then is x can be positive 2 square root of 3, and y is going to be positive 2. Or x can be the negative 2 square root of 3, and y will still be positive 2. And so here are my solutions. All right, so solve by method of choice. So I heard somebody say substitution. That was you? I didn't think so, but it's okay. So I'm assuming you're going to want to use the first one to solve for y. All right, so x cubed plus y equals 0. So subtract the x cubed, so we know y equals negative x cubed, correct? So then we're going to substitute that into the second equation. So 2x squared plus x cubed equals 0. Now what? We're not done, but good try. Yeah, common factor out an x squared. And then set them equal to 0. And then plug your x's back in to solve for your y. Well, you already told me, remember that y is equal to negative x cubed. So let's plug in when x is 0. So y equals negative 0 cubed. Now be careful. The negative's not being cubed. Honestly, it's not going to make a difference since it's a cube. It's an odd exponent, but if it had been an even exponent, it'd make a difference, okay? So cube the number first and then put a negative in front of it, but in this case it just happens to be 0. So that means that that solution, when x is 0, we know y is 0. And then do when x is negative 2. Same equation. Do we do the negative negative, or do we do the negative 2 cubed first? Negative 2 cubed first. So we get negative, what is negative 2 cubed? Negative 8, which gives me positive 8, right? And so when x is negative 2, we know y is positive 8. And there's our solutions.
Can I just do the second one?
Well, let's go ahead and let's look at both of the word problems and let's just set them up together, because then you're going to work it using the same way you've been doing. So the difference between the squares of two numbers is 3. So do we know those two numbers? No, but it says a difference, which means what? Subtract. And since we don't know the two numbers, let's call them what, x and y? But it says the difference between the squares of the two numbers, so let's call them x squared and y squared. Means equals 3. Twice the square of the first number, so what is that? Yeah, 2x squared is increased by the square of the second number. Yeah, just the y squared. Is 9. So it equals 9. There it goes. And so you just work it out from there. Okay? And the last one there says the area of a rectangular piece of cardboard is 216 square inches. What do you know about the area of a rectangle? Yeah, so that's telling us that length times width equals 216. The cardboard is used to make an open box by cutting a 2-inch square from each corner and turning up the sides. If the box is to have a volume of 224 cubic inches, find the length and the width that must be used. What do you know about volume? Yeah, length times width times height, or length times base times height, width times base times height, however you want to put it, okay? So, I am kind of visual, so real quick I'm going to draw this. It's an open box, and they cut out the corners, didn't they? And they cut out how much on each corner? 2 inches? So this is 2, this is 2, 2, 2. Alright, so its length here was L, but we just took away how much? 4. 2 from each end. And the width over here was W, but we just took away how much? Sorry, it's kind of hard to see there on the screen, but it does say W minus 4 over there. And so I know my length now. I know my width. What is the height of that box? Well, that's going to be this little piece right here when it's folded up, isn't it? This, let me go to a pink color because it'll show up better. Right here on the left, you see where I'm drawing that pink? Right here is kind of that line that we're going to fold it on. So this right here is the height of the box. So how high is it going to be? How big was that cutout? There's only one of them though. Alright, hold on just a second. Alright, I'm actually going to use a sheet of paper and show you this. Alright, so what we just saw there then is that piece right here is going to be the one that folds up, and so the height's going to be that 2. So when we go in to do this, you told me it's going to be the length times width times height equals the volume. So the length, remember, you said is L minus 4, times the width, which you said is W minus 4, times the height, which you said is 2, equals, and they told us our volume is 224. And so, yeah, you could go through and work that out to be able to solve for your length and your width. Piece of advice, use the first equation there, solve for either L or W, and plug it into the other one, okay? And also distribute the 2 into one of them so it doesn't look quite so confusing for you.